Hi everyone. Okay, so we're going to take on section 4.5. It's the last section in chapter 4. It really puts together everything that we've been learning in 4.3 and 4.4, but now we're solving rational equations. So what is a rational equation, right? Might be the first thing that might come to mind. So here would be an example of a rational equation. And you can jot down that a rational equation is an equation that contains a rational expression. So from the review on the understand page, an equation has an equal sign, right? So here's an equation with an equal sign that contains a rational expression, right? We know rational expression is a fraction, right, that has a polynomial divided by a polynomial. So these are very simple polynomials. This is a rational equation, and we have to solve it. This is the easiest type to solve, okay? And why it's the easiest type to solve is because when we see one fraction equals another fraction, right? Here's one fraction, and that 2, remember, any whole number I can make as a fraction, the denominator is 1. So when I see one fraction, just one fraction over here equals another fraction, we want to cross multiply, okay? So we're going to do a quick little mini review of cross multiply. So cross multiply, it's like two diagonal lines, okay? So I need to do 1 times 1, and I'm going to put my answer down here. 1 times 1 is going to give me 1. And then I'm going to go and zigzag the other way. 2 times x plus 4, and I'm going to jot it down here. Okay? So 1 times 1 is 1, right? That's why I wrote it right here. And then 2 times x plus 4, we'll just leave it as 2 times x plus 4. Okay, and that's all. We got rid of our fractions, super easy to multiply this way, and I can continue. Basically, once we get it like an equation, we need to solve for x using whatever method, using whatever method is necessary. In this case, it's just basic algebra, right? So I'm going to distribute this 2. Distribute the 2. So I'll get 1 equals 2x plus 8. And then I just got to isolate this x variable. So I subtract 8 from both sides. I get 1 minus 8 gives me negative 7 equals 2x. 2x, how do I get that x alone? Divide both sides by 2. And I could say x equals negative 7 over 2. And that's it. Okay? Super easy when I have one fraction equal another fraction. Just have to cross multiply and solve for x. 2 steps. Easy. Okay, you guys are going to try these try-its in the practice section. Okay, so now if you want to like pause this video and go and try those, that could be however you want to set this up. Okay, the next example that we're going to look at, we're going to go back to that question. Do I have one fraction equaling another fraction? I don't, right? It's so sad. I have 2 fractions that are being added over here equaling one fraction. So I have to get another plan, okay? My plan isn't cross multiply anymore. We can't do that. I need to get rid, oh my goodness, look at me. This sucks, guys. I need to get rid of the fractions ASAP, okay? And how we're going to get rid of the fractions is I need to find the common denominator. Okay, so it goes back to 4344. I need to find this common denominator. And how we're going to do this is factor all the denominators, right? So x minus 5 is already factored. I can't get any more simplified than that. X minus 3, can't get any more simplified than that. X squared minus 8x plus 15, I can factor that into x minus 3 times x minus 5. Okay, by factoring, I've realized that my common denominator is what? Anybody already see my common denominator? My common denominator is x minus 3 times x minus 5. Okay, so that's basic, going back to 4344, getting a common denominator. That's not new. Over here, this isn't new either. I want to make sure I know my domain. Right? Domain x cannot be 5 and 3, right? Zero product property to the factors in my denominators. So add 5 to both sides, positive 5, add 3 to both sides, positive 3. Okay? That's just a side note here. Really important though. Once I have my common denominator, remember, my plan is to get rid of the fractions. And I'm going to use this common denominator to get rid of the fractions by, here's this new plan right here, this new step. I need to multiply each side of the equation by the common denominator. Okay, so how I write that is I rewrite my equation in the factored form that we just did, and I put parentheses around the whole thing. I need to multiply this entire thing by my common denominator, x minus 3 times x minus 5. And basically what we have to do now is distribute these terms, this common denominator, to each fraction. So I need to bring this whole thing, multiply it over here, multiply it over here, and multiply it over here. Okay? It's really simple. Usually, and you'll see in the next one, we're not going to write this all out, but this time I did. Okay? So first thing, 1 over x minus 5 times my common denominator, x minus 3 times x minus 5 over 1, just to make it 2 fractions. What happens, guys, x minus 5 times x minus 5, those are going to cancel, right? That is x minus 5 over x minus 5, that's just 1. Remember, multiplying 2 fractions, 4. And what am I left with? X minus 3. Easy, okay? And notice I can now write that right here, x minus 3. So when I multiplied x minus 3 times x minus 5 by this fraction, I'm left with x minus 3. My fraction is gone. I'm going to do the same thing. X over x minus 3 times my common denominator, x minus 3 times x minus 5. What happens here? Now my x minus 3's cancel. And what am I left with in the numerator? X times x minus 5. No fraction. My denominator is 1. My fraction is gone. And this will happen every time. That's what I'm left with. So plus something over here equals my last distributing here, right? This whole fraction times my common denominator. Check this out. What happens here? The x minus 3's cancel because I'm multiplying, and my x minus 5's cancel because I'm multiplying. What am I left with? This equals 2. Okay? And this is the equation now I have to solve for x. That's what I'm left with. Doing this process, multiplying each side of the equation by the common denominator, got rid of my fractions. And now this is just a simple equation that we need to solve for x. Okay, back to that same step. Simplify. Solve for x using whatever method is necessary. Okay? And at first I see this x times x minus 5, so I'm going to distribute. This x to everything. So now I'm left with x minus 3 plus x squared minus 5x equals 2. I decided to combine like terms, so I have an x minus 5x, that gives me negative 4x, minus a 3 equals 2. I need to combine like terms even more, right? So I want to get that 2 to the other side. I want to get this equal to 0. Notice how now it equals 0, which is great. So I subtract the 2 to the other side. And now what I'm left with is x squared minus 4x minus 5. And I need to look at this and again say, how can I solve for x? Right? How am I going to solve this for x? It's a quadratic. What should come to mind? Factoring, right? Two numbers that multiply to negative 5, add to negative 4. It's going to be x minus 5 times x plus 1. How do I solve this for x? That lovely property, right? Zero product property, x minus 5 equals 0, x plus 1 equals 0. These are my solutions, okay? Let me know if I usually would say questions for me, so let me know, I guess, over in the comment section on Schoology, not YouTube. But we're not done. We're not done, guys, because let's go back up to the way beginning. Didn't we say that my domain x could not be 5 and 3? Because what would happen if I put 5 into my original equation? I would get 5 minus 5. Denominator would be 0, and I would not be able to solve this. Same thing with the 3. If I put 3 in here, denominator would be 0. It's undefined. That's why I said my domain x can be everything, all real numbers, except 5 and 3. But I just said x equals 5 and x equals negative 1. Okay, so I actually only have one answer, the negative 1, because x equals 5 is what we call, it's just extra, right? See that word right there? It's an extraneous solution, okay? X equals 5 is not my final solution. X equals 5 is called an extraneous solution, vocab, because it makes the value of the denominator in my original equation 0. Going back and looking at my domain, okay? So I would say now in class, on a quiz or a test, make sure you always go back and check your domain, right? That's why it was really important we did this in the beginning, because my domain, really easy to get here, 5 and 3. I better check that my final answer isn't a value that I'm excluding from my domain, okay? So make sure you always check with your domain, and your final solution might not be this, okay? Check to the domain, and then you're going to actually get your final solution. Okay, guys, again, you're going to go and do this one in the practice section. Let's try it in the practice section. Awesome job, guys. I'm going to stop this video, and the next video is one last example, and take a look at that too. Thanks, guys.